Hi, in this video we will look at the difference between cells and batteries, and we will look at various ways to set up electrical cells. And finally we will look at the difference between alkaline cells and rechargeable cells. Now, a good place to start a video on chemical cells and batteries is to clear up a common misconception. If you were asked what the image on screen shows, you would probably say it shows 4 batteries being recharged. Unfortunately, most people use the words cells and batteries as if they were the same thing, when they are not. Now, each of the cells shown in the image produces a voltage of 1.5 volts, and if all 4 cells were placed in a child's toy, for example, then they would form a battery which produces a total voltage of 6 volts. Now, a battery is simply a group of cells all joined together. So for example, a 12 volt car battery consists of 6 2-volt cells all connected together to give a total of 12 volts. Have you ever been in a rush to eat a packet of your favourite sweets and accidentally eaten some of the metal sweet wrapper by mistake? If you have, then you may have felt a sharp pain going through your tooth if the metal sweet wrapper came into contact with any metal in your fillings. The reason for this is that to make an electrochemical cell, all you need is 2 different metals in a solution that conducts electricity, that is, an electrolyte. In your mouth, you could have the metals aluminium or tin in the sweet wrapper, and there are the metals mercury, silver, tin and copper in any tooth fillings, while the alkaline saliva can act as an electrolyte. This means that in your mouth you have all the requirements to make an electrical cell, and the electrical current produced will shoot up the metal fillings in your tooth through the nerve and give you a feeling of a sharp pain. Perhaps the first electrical cell you ever made was using a piece of fruit, such as a lemon, orange or a lime. You may even have used a potato to make one of these simple electrical cells. All you have to do is stick 2 different strips of different metals into the fruits, and here the solutions inside the fruits will act as the electrolyte. Now, to make a simple electrical cell, we can replace the fruit and vegetables in the fruit cells with a solution of, say, sodium chloride or sodium nitrate. Both of these solutions contain an ionic compound dissolved in water, and hopefully you will recall that solutions of ionic compounds are good electrolytes, that is, they are electrical conductors. However, you should exercise some caution in the choice of the ionic compound to be dissolved to form your electrolyte. It is best to use one that will not react with any metal that is placed in it when making cells. For this reason, a sodium nitrate solution is often used, as it is a fairly inert electrolyte. Now, the image on screen shows 3 cells. In each of the cells there are 2 different metals dipped into a sodium nitrate electrolyte. A voltmeter or an ammeter can be placed in the circuit to record the cell voltage or the size of the electrical current flowing. In each of the cells there is a flow of electrons, that is, there is an electrical current flowing. Now, the electrons will flow from the metal highest in the reactivity series to the metals lowest in the reactivity series. Now, there are several factors that will affect the size of the voltage produced in each of the cells, but perhaps the most significant factors you should consider are: the further apart the 2 metals in the cell are in the reactivity series, the larger the voltage produced. So in the example shown, the 3rd cell contains the 2 metals magnesium and copper. These 2 metals are further apart in the reactivity series than the metals in the other 2 cells, so the 3rd cell will produce the largest cell voltage. Another factor which can affect the cell voltage is changing the electrolyte or the concentration of the electrolyte. Although great care is needed in the choice of the electrolyte solution, as we have said, and you must ensure that the electrolyte will not undergo a reaction with any metal strip, that is the electrode, which is dipped into it. Another way to set up cells is outlined below. This setup is often called a galvanic cell. Now in this cell, the two metals, copper and zinc, are placed in separate beakers containing a solution of their own ions. This prevents unwanted side reactions from occurring where the metals can react with the electrolyte and cause unwanted reactions that you didn't or hadn't planned for. The two metals are then connected by electrical leads to a voltmeter. However, if the two metals, copper and zinc, are in beakers containing solutions of their own ions, then there will be a gap in the circuit. This gap is filled with a salt bridge. Now this salt bridge can simply be a piece of filter paper soaked in an inert electrolyte, such as sodium nitrate or sodium sulfate. Now in the diagram shown, a more efficient salt bridge is used. Here, a glass tube is filled with a gel which is permeated with sodium sulfate or sodium nitrate solution. This salt bridge completes the circuit and maintains a balance of charge in the two beakers by allowing the free movement of sodium ions and nitrate ions between the beakers as the cell reactions take place. These ions in the salt bridge are inert and will take no part in the cell reactions. The ions simply migrate into the beakers to ensure electrical neutrality is maintained as the cell reactions take place. Now in this cell, since the zinc is the more reactive metal, it will be oxidized. It will form zinc ions and release 2 electrons. Now the zinc ions will dissolve in the zinc sulfate solution. A half equation for this oxidation reaction is also shown. The electrons which are released will travel through the wire and the voltmeter and head towards the copper electrode. Here the copper ions in solution will pick up these 2 electrons and will be reduced to form copper atoms which will collect on the electrode. An equation for this reduction reaction is also shown. Now you may have noticed that we may have a bit of a problem. That is, the left-hand beaker containing the zinc sulfate solution will end up with a positive charge simply because there is not enough negatively charged sulfate ions present in the beaker to cancel out the extra positive charges from the added zinc ions. While the right-hand beaker will end up with a negative charge due to the fact that the copper 2+ ions are being removed. This, of course, will lead to an excess of the negatively charged sulfate ions. If this situation actually occurred, then the cell reactions would immediately stop. However, this is where the salt bridge comes into play. The salt bridge contains the positively charged sodium ions and the negatively charged nitrate ions. Here, the negatively charged nitrate ions will simply migrate into the left-hand beaker and the positively charged sodium ions will simply migrate into the right-hand beaker, and in this way electrical neutrality will be maintained in both the beakers. Alkaline cells, such as the one shown in the image, are widely available in many stores, making them a convenient choice to power many low-power electrical devices such as remote controls, toys and torches. These alkaline cells also have a long shelf life and they can retain their charge for long periods of time even when they are not used. Now the chemicals inside these alkaline cells and batteries have stored chemical energy which is changed into more useful electrical energy when the chemicals react. However, once the chemicals inside these cells are used up, the cells are then simply thrown away, which, considering many of the chemicals inside these cells and batteries are harmful, is not a particularly environmentally friendly option. However, some cells and batteries when they go flat can be recharged. The cells and batteries inside smartphones and electric cars, for example, are recharged many hundreds of times. The chemical reactions that take place inside these cells are reversible, and when an external electric current is supplied, these cells are then essentially fully recharged. Though these rechargeable cells have a higher upfront cost compared to alkaline cells, they are a more environmentally friendly option. And some of these rechargeable cells, particularly the nickel metal hydride cells and the lithium ion cells, offer high density and can be used to power high-drain devices such as smartphones and digital cameras. Hi, thanks for watching. If you found this video helpful or would simply like more information, then why not visit the website that accompanies these videos? The links are in the description below. If you enjoyed the video, then please consider liking and subscribing. Thank you.